This is Mr. Beck Does Your Homework, AP Physics Homework 3.2, question number 10, part 1 and 2, so 10 and 11. A block is released from rest on an inclined plane and moves 2.2 meters during the next 4.7 seconds. The acceleration of gravity is 9.8 meters per second squared. What is the magnitude of the acceleration of the block? Well, that sounds like a equations of motion sort of thing. So I want the acceleration of the block. So my acceleration is what I'm looking for. I know it's released from rest. Well, that's an initial velocity of 0. It moves 2.2 meters, so x equals 2.2 meters during the next 4.7 seconds. That's a time of 4.7 seconds. Oops, 4.7 seconds. Can I get an acceleration out of that with an initial velocity, a distance, and a time? Sure I can. I know that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. So my initial velocity is 0, so that goes away. So I get 2.2 meters. It's going to be 1/2 of my acceleration times 4.7 squared. So that will easily solve for acceleration. 11 says, what is the coefficient of kinetic friction for the incline? Well, that's kind of interesting. With my acceleration now, I know that my net force is going to be my mass times my acceleration. So that's going to be 14 kilograms times my acceleration that I have from here, and that's going to give me some number for my net force. Well, what is my net force made of? Now I need my free body diagram. I've got gravity straight down. I have a friction force this way because they are asking for a coefficient of friction. I've got a normal force this way. Well, gravity down is going to split into two components, one into the ramp and one down the ramp. So this is going to be my Fg into the ramp, and this is going to be my Fg down the ramp, if this is Fg. So my Fg down the ramp is going to be my mass times gravity times the sine of theta, and my Fg into the ramp is going to be mg cosine theta. So I know m, I know g, I know theta, so I can figure out this one. Well, this one into the ramp is going to balance the normal force because it's not going to be moving in this direction in and out of the ramp. So my Fg, my normal force is the same as Fg in as mg cosine theta. Well, how do I find out my friction force? My force of friction must be mu times my normal force. So mu is really Ff over Fn, so I could write it that way. It's Ff over Fn. So I know my normal force. Now I need to find out my friction force, because then I can get mu. Well, my friction force, let's look at up and down the ramp. I have up the ramp is my force of friction, and down the ramp is my Fg down, which is mg sine theta. The difference between these is going to be my net force. Oh, I already know my net force from up here. So my F net is going to be Fg down minus my force of friction. So since I know my force of friction, I know my net force, yes. I know my gravity force down, yes. I can get my force of friction. So once I've solved for force of friction, now my coefficient of friction is my force of friction divided by my normal force. I will know that, I will know that. I get myself a coefficient of friction.